Good day. Let's quickly do this question number 8. That is the galvanic cell. The electrochemical cell represented by the cell notation below is used to investigate the relationship between the concentration and the EMF. The concentration of zinc ions and the temperature are kept at standard conditions. So this is the cell notation for the galvanic cell. What we do when we answer the questions given the cell notation, we must know that here there is the anode, then this is the salt bridge, then here we have the cathode, which means the zinc is the anode, then X is the what? Is the cathode. Okay, the graph shows the results obtained. So let's look at the graph. On the y-axis we have the EMF, then on the x-axis we have the concentration of X, and then on the y-axis we have the EMF. As you can see, remember we start by X then followed by Y, meaning that we can say here as the concentration of X2 ions increases, the EMF increases. We start on the x-axis because we say xy. As what is on the x-axis increases, what is happening on the y-axis, which means what is on the y-axis depends on what is written on the x-axis. Okay, now let's answer the questions. Question number 1. For this investigation, write down the dependent variable. So 8.1.1, write down the dependent variable. The dependent variable is the EMF. If you can look here, if you increase the concentration, then the EMF increases. Therefore, the dependent variable is the EMF in this case. As the concentration of X2 plus ion increases, the EMF increases, which means the EMF depends on the concentration of X ions. So let's go to 8.1.2. Name the instrument needed to measure the EMF. We use the voltmeter. We use the voltmeter to measure the voltage, to measure the EMF. So we use the voltmeter. Let's go to 8.1.3. Name of the component of the cell that ensures electrical neutrality. If you can look at this, this is the function of the salt bridge, to ensure the electrical neutrality, which means this is a salt bridge. Salt bridge. It ensures the electrical neutrality. 8.1.4. 8.1.4. The values of write down the values of 2 standard conditions needed to ensure that the standard EMF is obtained. So it should be the temperature. They say the values. Yeah. So the value of the temperature should be 25 degrees. Celsius, or is supposed to be 298 kelvins. So that is the temperature, standard temperature for the galvanic cell. Now they said write down two. The second one supposed to be the concentration, but they said the value it should be 1 mole per dm cube. Then the pressure, if there was a gas, but there is no gas here, so the pressure is wrong. So there are two conditions, standard conditions, that is 25 degrees Celsius or 298 kelvins. Then we have 1 mole per dm cube, that is the concentration. Now we are on 8.2. 8.2. Identify or write down the conclusion that can be drawn from the results. 8.2 conclusion here. What is happening on the graph as you increase the concentration of X ions, the EMF increases. We start with X, that is XY. As the concentration increases, the EMF increases. So as concentration of X ions increases, the EMF increases also. That is the conclusion that we have. Let's go to 8.3. Identify metal X with the aid of the calculations. If you can look here, X is the cathode, then Zn is an anode. So we are going to use this formula. E naught cell is equal to E naught of the cathode minus E naught of the anode. Okay. Then we can, if you can look at the graph, we have the concentration which is 1. That is a what? A standard condition. That is a standard condition for galvanic cell, which means this is the EMF that we are going to use, not this one, not this one, but this one, not even this one. The concentration is 1 here, therefore we're going to use that EMF, not this one, because the concentration here is 0.6, which is not standard. 0.2 is not standard, 0.1 is not standard, but this one is standard because we say the concentration must be 1 mole per dm cube. Then we say it's a standard condition as. Then let's go to the question. So E naught cell supposed to be 0.11. E naught cell, that is the EMF of the cell for standard condition. EMF of the cell for standard condition. So it's 0.1, or it's 1.11, not 0.11. 1.11. Then we are looking for the cathode. minus. Then the anode is the zinc. Let's go for the zinc to the table. This is the standard reduction potential table. This is the zinc, which is minus 0.76. Minus 0.76. Minus 0.76. Then we have 1.11, which is equal to E naught of the cathode. Negative times negative supposed to be positive, 0.76. Then we transpose this one to this side. 1.11 minus 0.76 is equal to E naught of the cathode. Therefore, E naught of the cathode is equal to 0.35 volts. Then let's go to the table and look for 0.35. Let's go back. 0.35, 0.35, positive 0.35, positive 0.35. Supposed to be this one. That is copper. Therefore, X is a copper. X is a copper. X is a copper. That is Cu. Let's go to another question, which is question number 8.4. This is 8.4. Write down the overall or net cell reaction that takes place when this cell is in operation. Now we have a copper and a zinc. We must go back to the table. Let's go back to the table. This is the table. This is 4B. 4B. Then let's look for zinc. This is zinc. Then let's look for the copper. Let's go down. This is the copper. So we are going to start with the zinc. We have the zinc 2 plus 2 electrons. Then we have zinc here. Then we have Cu2 plus 2 electrons. Then we get Cu here. There is this arrow. There is that arrow. So we have a reducing agent here. Strength of reducing agent here. Strength of oxidizing agent. Then sibhale anti-clockwise arrow to par. So this simply means that we are going to choose this arrow for zinc. Then for this one, we're going to choose the arrow that go to the right. So we have a zinc. We're going to start with this one. That is the Zn, which forms Zn2 plus 2 electrons. So the zinc is losing what? Electrons. That is NOx. So we have Cu2 plus 2 electrons. Then we get Cu. The Cu2 plus is gaining electrons. That is a red cat. That is a reduction at the cathode. Then the net reaction will be like we're going to cancel this and this. Then we get Zn, this one plus this one plus Cu2 plus, then to form this one, that is Zn2 plus Cu. So everything is balanced. That is that's supposed to be 8.4. 8.4 is answer. Then we're done with this question. Let's do another question on galvanic cell.